Okay, so this is a short video on resonance. We had mentioned it's a couple of structures above what resonance was, but formally, resonance is a term which means that it is possible to draw a double bond between the same two atoms on a Lewis dot structure and still have a properly drawn structure. So which structures in the drawings above fit that description? Well, you can go back through your notes and write down those. Look at your structure for the carbonate ion. It appears that there is one double bond and two single bonds. This would mean that one bond is shorter and stronger than the others. However, empirical data, which is data gathered through experimentation, mainly obtained through spectrometry methods, we'll do a little bit of those for AP Chem, has determined that all three of the CO bonds are identical in length, between the strength of a single bond and a double bond. This is resonance. It is as if the shared electrons in the double bond are being shared equally throughout the entire molecule. To properly represent a resonance, all possible structures must be drawn with double arrows in between. And so let's look at what that looks like. I'm going to try to add some note space here. So give me a minute. If I can remember how to do that. Add a page. Okay, so let's go down here and let's draw CO3. Okay, we'll start out with one carbon, 3 oxygens, 2 electrons. Okay, and so you have a total of, I believe, 24? Yeah, 24. Okay, so I'm going to scroll down just a little bit. You've got carbon, oxygen, oxygen, oxygen. It doesn't matter where you put the oxygens, I just kind of space them around. Okay, we make our initial bonds here. Of the 24, we've used 6, we have 18 left. Distribute the rest around oxygen as pairs. And if you look, we've used all 24. Okay, so this is one where we wanted to make carbon happy. So we erase a pair and we make a double bond. Now this atom, or all the atoms are satisfied. You're going to hear my kids in the background. Archer, go in the other room. Okay, so why did we pick this oxygen? We could have picked this oxygen or this oxygen. Okay, so what that means is that there's two other possible variations of this structure. So we draw all 3 structures. Now you know that it's pretty quick. You can just double bond. Okay, these will have 6 around. The ones with double bonds will only have 4. And then we draw a third structure with the double bond, and kind of running out of room over here. I don't know if you can see that. Hopefully you can. All of these, by the way, would have brackets. And we would connect them with a double arrow in between them. But since I kind of squished all my work, I'm going to write to the side. And so what you have here is you have 3 possible structures showing the double bond at a different point. Okay, and what this represents is that the electrons actually bounce between the 3 oxygens equally, and all of them have equal bond lengths. Okay, so we're going to stop the video here.